Equation of a straight line is the topic of this video. Now, we're going to find the equation of a straight line when you're given a point and the direction of the vector using vector method. So let's move on. You can find this equation in three different forms. The first form would be called the parametric form. Okay, so what does that mean? So you're going to use a parameter, and the parameter that we'll be using is t. Anyway, let's see how we can explain. Now start to visualize a three-dimensional space, and let's call this as our x-axis, y-axis, and our z-axis. So on this, let O be our point of origin. First, I'm going to define a line here and define this point as point A. And this, I'm going to call this as my vector A. And this is my second vector, which is vector B. Okay, so we are given a point A. So I can define this point as A, B, C, the coordinate A, B, C. Okay, so that's A. So you have the vector A, then you have vector B. Now we're going to draw a line which is parallel to vector B, and it's going to pass through A. So from A or through A, it's going to pass and it's going to be parallel to vector B. So let's do that. So that's our line. Now I'm going to mark another point here, P, and call this as my vector R. Okay, those steps were very simple. So now you have a line AP, or you can call this as vector AP, which is parallel to vector B, and it passes through the coordinate or the point A. So we can define the vector R as equal to A plus AP, correct? Vector A plus vector AP. So in other words, AP vector will be equal to R minus A vector. So this is my first part of the solution. Next, we're going to take this vector B and define AP in terms of B. Since vector B is a multiple of vector AP, we do not know the exact length of AP, but it's parallel to vector B, so we can multiply vector B can be multiplied with a scalar t to give you the vector AP. Okay, so I hope that was easy, where t belongs to R. So keeping this as our number 2 and equating these two, we will get R minus A is equal to TB. So you can write this as vector R is equal to vector A plus TB vector. So that's the equation of the straight line that we were supposed to find. Now, what does this actually mean? I want you to visualize this, look at it in a practical sense. This is my vector R, and t is a parameter. So as the value of t keeps changing, the point P will keep shifting, because A plus t times of AB will give you AP. So as the value of t changes, the point P will keep shifting and our vector R will keep moving. Is that clear? So what do we get? By changing the value of t, we will be able to get all the points on this line AP. You will get all the points on this line. This is an array. Then you will be able to plot all those points here, and the vector R will keep changing its direction based on where P lies. So you will be able to find all these points or all these position vectors R's using this equation. I hope that was clear. So next, let's move on to the second method. The second method is called non-parametric method. So in this method, we don't use a parameter. So before I explain all of this, let me just put it down for you. We know that our AP times vector B will be 0 vector because they are both parallel. Okay. And we also we can say that the vector R minus A, which is my AP, times B is equal to 0. Right? AP is, we know this vector AP is equal to R minus A. Okay. Expressing the straight line in the form R minus A into B is equal to 0 vector is called a non-parametric form of expressing this vector equation. Now let's look at the last one. The third form is called the Cartesian equation form. Okay, so in this equation, what we do is, let's first consider our vector A, vector R, vector AP, and let's also consider our vector B. And we will define this point here as B1, B2, B3, and define A as the point A as X1, Y1, Z1. Okay, and let's represent P as X, Y, Z. So these are the coordinates of A. Okay, this is the coordinate of A, and that's P, and we can define this point as B. So this is my coordinate B. So we can write our vector B as this, and vector A can be written as this, and our vector R can be written as this. Okay, so let's bring the parametric form here. The parametric form says vector R is equal to vector A plus TB vector. Okay, now let's substitute the values of R, A, and B. R is X I cap plus Y j cap plus Z k cap is equal to our A vector is X1 I cap plus Y1 j cap plus Z1 k cap plus T times, what's our B vector? B vector is B1 I cap plus B2 j cap plus B3 k cap. Okay. Now further simplifying this, let's move this term to our left hand side and bring the coefficients of I cap, j cap, and k cap common. So this will become X minus X1 I cap. Okay, X, when it comes to this side, it's minus X1, and we're making I cap common, plus Y minus Y1 j cap plus Z minus Z1 k cap is equal to, now let's multiply T with each of the terms inside. You will get TB1 I cap plus TB2 j cap plus TB3 k cap. Okay, now let's equate or bring the coefficients of I cap, j cap, and k cap separately. So the coefficient of I cap is here X minus X1 and in this side it's t b1. So you can say this is equal to this. X minus x1 is equal to t b1. Yeah, the coefficients of I cap on both sides, they are unique. So this has to be equal to this. So this you can further write as t is equal to x minus x1 divided by b1. Alright, so bringing the b1 here down, so this becomes x minus x1 divided by b1, that's t. Similarly, the second one, you can write it as y minus y1 is equal to t b2. So that becomes our t is equal to y minus y1 divided by b2. Similarly, we can bring z minus z1 is equal to t b3. That means our t is equal to z minus z1 divided by b3. This is z. Okay. So you can see that t is equal to this, t is equal to this and this. So let's equate these three terms. So we can define x minus x1 by b1 equal to minus y1 divided by b2 is equal to z minus z1 by b3. This is called the Cartesian form of representing the equation. So we have seen all the three methods of writing a vector equation given a point and a parallel vector. Let's try and solve a problem. Okay, the problem says a straight line passes through the point 1, 2, 3. So this is my straight line that I need to find. So I'm going to define this as point A, and I'm going to call this as 1, 2, and minus 3. And parallel to 4i cap plus 5j cap plus minus 7k cap. So this will be my vector B. So this is my vector B. This is origin. Find vector equation in parametric form, vector equation in non-parametric form, Cartesian equations of the straight line. Okay, so let's start with the first one, which is the parametric form. Okay, so our A vector is now defined as I cap plus 2j cap minus 3k cap. Okay, so a point A. Then our vector B is now defined as 4i cap plus 5j cap minus 7k cap, or vector B, which is here. So that's a vector B. So our equation of the straight line is given by a vector R is equal to vector A plus t times vector B, where t belongs to R. So replacing the values of vector A and vector B, you get our vector is equal to I cap plus 2j cap minus 3k cap plus t times 4i cap plus 5j cap minus 7k cap. So that's our equation, and don't forget t belongs to R. So that's the parametric form. Our second method is non-parametric form. Okay, so we have our vector A and vector B, and the equation of a non-metric form is vector R minus vector A into vector B is equal to 0 vector. So now let's substitute the values of A and B. So you get R vector minus value of A vector is I cap plus 2j cap minus 3k cap into vector B, which is equal to 0 vector. So this is our non-parametric form. Right, so that was quite simple. Now let's do the third one, which is the Cartesian equations. Okay, how can we do this? We know that the Cartesian equation is x minus x1 by b1 is equal to y minus y1 by b2, and that's equal to z minus z1 by b3. So here our x1, y1 and z1 is the coefficients of I, j cap and k cap of vector A. So that would be 1, 2 and minus 3, which is the Cartesian point. You know, like that's the coordinate of point A. And you can define the B1, B2, B3 as 4, 5, minus 7. Also, they are the direction ratios for the required line. Since the line is parallel to vector B, these will be the direction ratios. So let's substitute in the equation. So you get x minus 1 by 4 is equal to y minus 2 by 5 is equal to z plus 3 by minus 7. So that's our Cartesian equation. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.